Assalamu alaikum. Today is our lecture 11 and today we will talk about the resistor in series and parallel. We will do some numerical in that. First we will do some series resistor in series numerical, then we will do resistor in parallel, and in the end we will do some combine exercise for that. So let's start with the resistor in series. In our previous chapter we studied about what is resistor, what is resistance, and what are the symbols for that. So from this symbol you can clearly understand that here we are talking about the resistor. So what is resistor or resistance in series? If we connect the resistors across a source such that the ending point of one resistor is joined with starting point of another resistor, then they are said to be connected in series. The combined effect of all the resistors will be equal to the sum of individual resistance. Consider two resistance R1 and R2 with terminal A, B, C, D as shown in the figure. So the meaning of this is that if we have two resistors, for instance we have R1 and R2 here, this one and this one, and we name the terminals of these are A, B, C and D. So when these resistors will be in series, these resistors will be considered in series only when the end of one resistor is connected with the starting point of another resistance. How? We can see in next slide. See, this was the end part of one resistor and this was the starting point of resistor 2. So here we connect them. So if the resistor is connected in such a manner that the ending point of one resistor connected with the starting point of another resistor without having any junction or any connector in between them, that is called that resistors are connected in series. And when we want to calculate the value of total resistance, then what we will do, the combined effect will be R1 R2. This means the combined effect will be, we will just add the values. What we did in capacitor in our last lecture was that in parallel we add and in series we take reciprocal, but in resistor it's the other way. In resistor, when we are in series we will just add them. So there were two resistors R1 and R2 and their combined effect will be R1 plus R2. So no matter how many numbers of resistors we will add here, we will just simply add them to get the final value of all the resistance connected in the series. Now take one example. Look at this circuit. It has two terminals A and B and two resistors are connected, 1 kilo ohm value for each. So if we divide these resistors like this is the one terminal, this is the two terminal, and this is our second resistor, first terminal and second terminal. So the ending point of one resistor is connected with the starting point of another resistor without having any junction or joint or connector in between them. So this means 1 kilo ohm, two resistors are connected in series with each other. So now we solve it, because we already know if the resistors are connected in series, the sum of all the resistors will be equal to the final value. So this is our 1 kilo ohm resistor and this is also our 1 kilo ohm resistor. So combined effect will be 1k plus 1k is equal to 2 kilo ohm. So the combined effect of both resistors are 2 kilo ohm. So let's do one more example. Here there are 4 resistors and we have to check if they are in series. So we divide both points of the resistors. This is the second point of second resistor, starting point of third resistor, ending point of third resistor, starting point of fourth resistor. So first is connected to second, second is connected to third, and third is connected with fourth. So this means all these 4 resistors are connected in series. So what you have to do is to solve this circuit step by step. No need to just write the combined effect or answer because it's very simple. We already know that just we have to add them. So 2 plus 3, 5 plus 4, 9 plus 1. We already know that the value is 10. 10 is the combined effect for this. But we have to do step by step. How? First we will start from the end. We will take these two resistors and we will apply series formula, that is plus. So we are taking 1 plus 4. What will be the answer? Answer will be 5 kilo ohm. Now we will add the last and second last resistor, that is 5 plus 3. So we have 8. Now we are left with the two resistors which are connected in series with each other. So the combined effect will be 8 plus 2, that is 10 kilo ohm. So in the starting we already know that the answer was 10, but in order to solve it in exam we have to do step by step. So first, it doesn't know compulsory that you start from the right side or left side. From any side you can start solving the circuit, but it's better you start from the right side to get because this is only series. In exams you will get series and parallel combined. So when there is combined, don't start from the starting point, try to start from the right side. So this was the resistor in series. Now we'll go towards the resistor in parallel. Resistors are in parallel if their terminals are connected to the same two nodes. The equivalent overall resistance is smaller than the smallest parallel resistor. Consider two resistance with terminal A, B and C and D as shown in the figure. If we connect A with C and B with D, they are said to be connected in parallel. Now, if you understand this line, resistors are in parallel if their terminals are connected to the same node. What do you mean by same node? You remember in series, we just add the ending point of one resistor with the starting point of another resistor. But in parallel, it is said that resistors are in parallel if the terminals are connected to the same nodes. Same nodes mean this is the starting node of resistor and this is the ending node of the resistor. If the starting node is connected with the starting node of another resistor and the ending node is connected with the ending node of resistor, another resistor, only then the resistors are considered to be connected in parallel. For example, we connect R1 and R2 in parallel. The starting point of resistor 1 was A it was connected with the starting point of resistor 2 by this line. So the ending point B is connected with the ending point D. So in this diagram, the starting point is connected with the starting point and ending point is connected with the ending point. So if such a scenario is there, so this means resistors are attached or connected in parallel to each other. So if the resistors are parallel to each other, how we will do that? We will do it by the formula 1 by R plus 1 by R2, or you can say the reciprocal that we took in our capacitor also. How? Both values multiplied divided by their product. So let's do one example. Let's take first example. So this is resistor 1 and this is starting point. This is resistor 2 and this is their ending point. This is our resistor 2 and this is the starting point and this is the ending point. So the starting point are both connected with each other and the ending point is also connected with each other. So this means the both resistors are connected in parallel to each other. So how we'll solve that? We'll take the reciprocal. 1 and 1 both are of 1 kilo ohm values. So 1 into 1 divided by 1 plus 1, that is 1 by 2, and the final answer is 0.5. So take one more example. This is the starting point. This is the starting point for this resistor and this is the starting point for this resistor, and these are the ending points. So all these three resistors are in parallel to each other. So let's start from the right side from here. First we are going to solve these two resistors. So what was the formula? Both values 4 into 4 divided by 4 plus 4. So the answer combined effect is 2 kilo ohm. So this is the 2 kilo ohm answer. Now we are left with the two resistors. They are both parallel to each other. So now how we will solve? 2 into 2 divided by 2 plus 2. So the combined effect is 1 kilo ohm. So the overall combined effect of these three resistors is 1 kilo ohm. Okay, we complete our series and parallel. In series we just add them and in parallel we take the reciprocal. So now we have a circuit and we check if it is a series or a parallel. So this is the starting point. This is the ending point of this resistor, and this is the starting point of this resistor, ending point, this is ending point, this is starting point, this is ending point, and this is starting point. Now we are left with this. So here we can say the starting point and here we can say the ending point of third resistor. So here we say the 2 kilo ohm resistor ending point is connected with the starting point of 4 km. So this means these two resistors are in series with each other, but the starting point of 4 kilo ohm is connected with the starting point of 12 kilo ohm. So this means these two are in parallel with each other. So in this circuit we have two resistors in series with each other and last one, these two are in parallel with each other. So how we'll solve that? We'll solve step by step. First we will solve the parallel one. These two are in parallel with each other. So what is the formula for parallel solving? 4 into 12 divided by 4 plus 12. So the combined effect is 3 kilo ohm. So 3 kilo ohm is their combined effect, and we have the remaining 2 kilo ohm resistor. So these two are in series because the ending point is connected with the starting point. So how we will solve that in series? We will just simply add them. 3 plus 2 is equal to 5. So the answer for this circuit is 5 kilo ohm. So you see, first of all, the first step is we have to find out are they in series with each other or parallel, and then we step by step start solving that. So here we understand how we solve the series circuits, parallel, and how we will do the combined circuit also. So this is the practice numerical for you all. Here we have 1 2 3 4 5 resistors, and some are in series with each other and some are in parallel to each other. So you have to solve this step by step, and in next lecture I will provide you the solution, but before that you do the practice for that yourself for your better understanding. So thank you for today's lecture.